This question falls under the topic of binomial theorem, so it requires some basic understanding of binomial expansion. So I will briefly explain what binomial expansion is about. Okay, if I assume that you should be familiar with how to expand this, right? We can use special identities, or we can just expand it normally, right? X plus y squared is the same as x plus y times x plus y. We get x squared plus xy plus yx plus y squared. So you end up with x squared plus 2xy plus y squared. Okay? So if you have x plus y cubed, you can see how it might be more tedious. X plus y cubed. So x plus y cubed, you can think of it as x plus y squared times x plus y, right? And this is x plus y squared. So we can just take the expanded form of what we have already found and then multiply by x plus y. And then just repeat that, right? Just expand from here. But you can see how it'll be tedious, okay? And then if we go even higher, like x plus y to the power of 4, it will be the answer that we found, right? Whatever that is, times x plus y again. Okay, so a binomial theorem is what will allow us to skip these steps, okay, and have a systematic way of expanding this. Basically, they just discovered that there's a pattern to the expansion. Okay, so learning how the pattern works is what this chapter deals with. All right, let me try to demonstrate what the pattern looks like. Okay, using x plus y to the power of 3 as an example, right? Uh, we start off with 3 choose 0, okay, and then there'll be some expression here, plus 3 choose 1, some expression there, 3 choose 2, and then finally we have 3 choose 3, okay. So yeah, let's observe the pattern part by part, right? So it's easier to see what's going on. Okay, the 3 down here at the top, this comes from the power outside the bracket, okay, and then the bottom number is just ascending order starting from 0. So the first term will be 0, second term will be 1, and so on and so forth. Okay, so just observe that the bottom number is always 1 less than the term number. Alright? You don't have to understand what like 3 choose 0, 3 choose 1, 3 choose 2 means, right? Just know that you can type this into your calculator, right? 3 choose 2, and then your calculator will give you the answer. Okay, so just be aware of that. Alright. Then the next term that you need to observe is the first term in the bracket. Okay, x. It will be x to the power of the top number minus the bottom number. So 3 minus 0. Right? Same for the next term, x to the power of 3 minus 1, x to the power of 3 minus 2, x to the power of 3 minus 3. Okay? And then finally, the last term will be y to the power of the bottom number. Y to the power of 0, y to the power of 1, y to the power of 2, y to the power of 3. Okay, so this is how the expansion looks like. We can also express this in terms of the general term. So what do I mean by the general term? The general term looks like that. N choose r, x to the power of n minus r, y to the power of r. Okay? N is the power outside the brackets. So it's 3, right? R will depend on which term you're looking at. If it's the first term, it will be 0. Okay? So, for example, if how can I use the general term, right? If I have certain pieces of information, based on this, I can write what that specific term is. For example, if I'm looking for the second term, okay, and I know that n, right, based on the question above, n is 3, okay, and since it's the second term, r must be 1, right, because r is always 1 less than the term number. Then I just fill it in. 3 choose 1, x to the power of 3 minus 1, y to the power of 1. Okay, then I just type this into the calculator. 3 choose 1 will be 3, so it will be 3x squared y. This will be the second term in the whole expansion. It's not the whole expansion, it's just the second term only. So that's how you can use the general term. Okay, so how is the general term useful for this question, right? Let me clean this up a bit. Move this to the side. Okay. Because you see, the question, they give you some pieces of information, namely that the coefficients of the fourth term to the third term is 5b. So that means that you can express the coefficient of the fourth term over the coefficient of the third term, and this will be equal to 5b over 1, right? That's what the ratio means. Okay, so if you can find the coefficient of the fourth term and the coefficient of the third term, you just sub into the equation and then solve for the required value. Okay, So by the way, coefficient, take note, right? Coefficient does not include the x term, right? So yeah, let me just go ahead and find what the fourth term is. So for the fourth term, we know that r must be 3 because r is one less than the term number. Okay, then we use the general term, right? N choose 3, the first term to the power of n minus 3. 1 to the power of anything is just 1. So, right, but let's just write it there first. And then the second term, bx squared to the power of 3. Okay, if we expand this, we will have n choose 3, 1. Okay, since 1 to the power of anything is just 1, we can just leave it out, right? You get b cubed x to the power of 6. This is the coefficient, right? So we ignore x to the power of 6. Okay, then the third term, we do the same thing, right? R equals to 2. So we will have n choose 2, 1 to the power of n minus 2, bx squared to the power of 2. And this becomes n choose 2, 1 to the power of anything is still 1, b squared x to the power of 4. Okay, this is our coefficient, right? But I realized for part A, right, they don't just require the coefficient, they require the entire term, right? So we got to include x to the power of 6 and x to the power of 4. Okay, so for part A, the third term is n choose 2, b squared x to the power of 4, right? But we can't just leave n choose 2 as it is, we need to expand it out. And that's a problem, right? Because normally when we have like maybe 3 choose 1, we will just type that into the calculator and then the calculator will tell us that it's 3, right? So we need to manually expand this because we can't type n choose 2 into the calculator, right? It's not going to give us the expanded form. So n choose r, there's a formula for this, right? It's n factorial over n minus r factorial times r factorial, which looks really complicated, okay? So it's easier to illustrate with a real example. So let me just, I'm going to use 6 choose 2. Okay. So n is 6. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay. So let me repeat that. 6 factorial is just, you got to multiply numbers going backwards from 6, right? In descending order, 6 times 5 times 4. Yeah. So the same applies to 4 factorial, just 4 times 3 times 2 times 1. You get the idea, right? Okay. Then at the bottom in the denominator, we have n minus r factorial. So our n is 6, r is 2. So n minus r is 4. 4 factorial will be 4 times 3 times 2 times 1. Okay? And then r factorial, that's 2, right? 2 factorial is just 2 times 1. Okay? It still looks very tedious here, but notice that at the bottom, we have 4 times 3 times 2 times 1. And we have that at the top as well. Okay? So we can simplify that and it cancels out. We will just have 6 times 5 over 2 times 1. Okay, so I'll show you another example to illustrate that there's actually a pattern that will help us simplify the expansion of this. Okay, I'm going to use 7 choose 3 now. Okay, 7 choose 3. At the top we will have 7 factorial, so that's 7 times 6 times 5, 4, 3, 2, 1. Below we will have 7 minus 3, so that's 4, 4 factorial, 4 times 3 times 2 times 1. And then times r factorial, which is 3 factorial, that's 3 times 2 times 1. Again, we're going to simplify it, right? We cancel out 4 times 3 times 2 times 1 with the 1 at the top. So we are left with 7 times 6 times 5 over 3 times 2 times 1. Okay, so let me draw your attention to the number of terms in the numerator. Okay, in 7 choose 3, right, the number of terms in the numerator is 3. In 6 choose 2, the number of terms in the numerator is 2. So the bottom term indicates, the bottom term indicates how many terms there are in the numerator, right? So if we have n choose 2, for example, right, we will have 2 terms at the top, right? So it will be, one of them will be n, and then the next one will be 1 less than n, right? Which is n minus 1, right? Because like for 6 choose 2 is 6 and then times 5, right? 5 is 1 less than 6. For 7 choose 3 is 7 and then times 6. Okay, so that's why it's n times n minus 1. Then in the bottom, we are just left with 2 factorial, so it's 2 times 1. Alright, okay, so with this in mind, we can now expand the third term. Okay, the third term will become, n times n minus 1 over 2, right? Or over 2 times 1, b squared x to the power of 4. 2 times 1 is just 2, right? Okay, this will be our third term. Then our fourth term will be n choose 3 b cubed x to the power 6, right? That's what we found here. Okay, and n choose 3, there are 3 terms in the numerator, right? So it's n times n minus 1 times n minus 2, okay? And then 3 factorial in the bottom. 3 times 2 times 1, b cubed x to the power 6. So it's simply n times n minus 1 times n minus 2 over 6 b cubed x to the power 6. So these are the answers for part A. Okay, for part B, now we have to make use of the information given that the coefficient of the fourth term over the coefficient of the third term equals to 5b over 1. Okay, so yeah, like I was mentioning just now, we got to exclude the x term. Okay, so we just take the n and the b terms, right? So the coefficient of the fourth term is just n times n minus 1 times n minus 2 over 6 b cubed over the coefficient of the third term, which is n times n minus 1 over 2 b squared. Okay, and this should give us 5b over 1. All right, so yeah, it looks kind of complicated, but let's combine the numerator into a single fraction and the denominator into a single fraction. Okay, so at the top, we can just put the b cube, because okay, if you times b cube, you can change b cube to b cube over 1, right? Then fraction times fraction, you'll just take the numerator and multiply by each other. You have n times n minus 1 times n minus 2 b cube over 6. And in the denominator, it'll be the same thing, right? So you have n times n minus 1 b squared over 2. So now you have a fraction divided by a fraction. And if you write that out in a straight line, it'll be easier to deal with. Okay, divided by n times n minus 1 b squared over 2. So for division of fractions, right, you change the divide sign to a multiplication sign, and then you flip the fraction on the right. Okay, and then you'll realize that actually a lot of the terms cancel out. Okay, 2 and 6, you can simplify that. N will simplify diagonally, and so does n minus 1. B squared and b cubed will also simplify. So b squared becomes 1, b cubed just becomes b. Alright, we'll continue the working up here. So what we are left with is just n minus 2 times b over 3 times 1. So it's just n minus 2 times b over 3. Okay, and this equals to 5b over 1, which is just 5b. Alright, then to get rid of the denominator in the bottom, right, we're just going to times 3 to both sides. So I'll get n minus 2 times b equals to 15b. Okay, then we're going to expand this. We'll get n minus 2. Oh, no, since we have b on both sides, right, we can just divide both sides by b. So we are then left with n minus 2 equals to 15. Okay, and if we add 2 on both sides, we can solve for n. So n is just 17. That's how you solve part B.